4.4.3a. Given the demand function P equals 1700 e to the negative q over 190, find the value for the elasticity of demand eta when q equals 152. Determine whether demand is elastic, inelastic, or has unit elasticity for q equals 152. Okay, in 4.4.3, it reminds us of the definition of elasticity, and it reminds us how to tell if it's inelastic, elastic, or unit elastic. It has to do with whether the absolute value of eta is less than 1, that would be inelastic, greater than 1, that's elastic, or equal to 1, and that's unit elastic. Okay? So we need a formula to calculate eta. And down near the bottom of 4.4.3, it gives us the formula we need, or formulas we may need. And it has to do with whether Q equals F of P or P equals F of Q. So let's take a look at our problem and see whether they gave us the demand in P equals or Q equals form. They gave us P equals. Okay, P equals, and then it gave us a function with a Q in it. So we're looking for the one with P equals, and that's number 2 here. If the demand equation is in the form P equals F of Q, then eta equals P over Q times 1 over P prime. And it gave us a value to plug in for Q. We're going to have to figure out what we need for P, and then we'll have to figure out our P prime as well. We'll be able to estimate that. Okay, so let's go back to the problem, and I'm going to pull up Excel and do my calculations in Excel. All right, so we need, let's see, some P's and Q's, and I want to write them in the form Q and then P, right? Our points in the form Q comma P, because P equals F of Q. All right, so I know that I'm going to need for 152, I'm going to need to know the corresponding P value. I'm also going to have to figure out the slope around Q equals 152. So what I'm going to do is pick some numbers really close to 152, like how about 151.9 and 152.1. All right, and then I'm going to plug in my function, which is 1700 times, and remember to do E, you do exp, it's a function, and you put the exponent in the parentheses. But please be careful, when you see negative and there's not a number after it, Excel is not going to do well with just a dangling negative. You're going to have to call that -1 times, and then I want to click on the 152, okay, and then divide by 190. All right, so make sure with Excel that you don't ever just put this negative, unless it's something that's actually being subtracted. But negative Q, it would totally do that incorrectly if I just put the negative without the 1. All right, so -1 times, and then I clicked on my 152, and so on. Now this is just going to give me the Q value, or excuse me, the P value that I need on the top of this fraction. I also need the P prime value, and to do the P prime I need values close to 152. Okay, and because this is Excel, I can either just double click or drag that down, and I have those P values to make my slope. All right, let's calculate the slope now. And the slope is the P prime. All right, so I did equals, parentheses, and then I'm going to do the 763 minus the 764. It's like y2 minus y1 over x2 minus x1. And then 152.1 minus 151.9. All right, so I just clicked those values. I didn't have to type them in again. That should be my P prime. Okay, so now I'm ready to calculate eta. So the elasticity is going to equal, I need the P value when Q is 152, so that's 763.85, etc., divided by the Q value, which is exactly 152, and then times 1 divided by P prime, and that was the negative 4.0203, etc. Okay, so hopefully this is going to tell us our elasticity. Negative 1.249999. Okay, so we're obviously going to round that to negative 1.25. And remember that it's said in 4.4.3, if that absolute value is greater than 1, it's elastic. Does this say elastic? It does. So that's a good sign. Let's see if B is the right answer. So be sure to practice this one several times.